Good afternoon. I am now going to describe online hemodiafiltration, which has become the gold standard of renal replacement therapy, both for chronic kidney disease, where trials like the Eschol trial and the Convince trial have shown a mortality reduction, and also in acute kidney injury in the form of sustained low efficiency hemodiafiltration. If we are to do online hemodiafiltration, there are some prerequisites. We need ultra pure water, traditionally done with the aid of double pass reverse osmosis. However, in units in our country which perform both hemodialysis and online hemodiafiltration, it may become wasteful to have all water processed by a double pass RO. We circumvent this problem by using highly purified water. It's a single pass reverse osmosis system, and then introducing a portable reverse osmosis unit between our normal water line and the dialysis machine. If you can afford it, Fresenius produces a portable RO machine called the Aqua WTU, which produces about 100 liters per hour of water. However, as this machine is expensive, we built our own machine with the help of a manufacturer from Mumbai. This machine allows us to produce ultra pure water at around 70 liters per hour, sufficient to run 1 to 2 hemodiafiltrations at any given time. We also require the use of a high flux dialyzer and special tubing sets for the 5008 online machine, and the use of sterile bicarbonate, which comes in a powder cartridge form rather than the liquid bicarbonate traditionally used during hemodialysis. Finally, we need a machine that is capable of producing a sterile ultra pure fluid which has a bacterial count of less than 1 in 1,000 liters and an endotoxin level of 0.03 endotoxin units per ml or less. This is done by machines like the Gambro AK200 Ultra and the Fresenius 5008 with the help of cold sterilization. That is, the dialysate fluid is sequentially passed through 2 ultra filters. In the case of Fresenius, the Diasafe Plus, each of which produces a 2 log reduction in bacteria and a 10 times reduction in endotoxin. We are going to perform an online hemodiafiltration on the Fresenius 5008 machine. As you can see, the machine has a very user-friendly interface with a touch screen. Its menus, the dialysate menu, the ultrafiltration menu, and the online menu are here on the main screen. It also has, in addition to the blood pump, it has a substitution fluid pump which will deliver the sterile substitution fluid, and the substitution fluid is obtained from the substitution port here on the machine, and the prime is dumped to the rinse port of the machine. In order to prepare the dialysate, the machine is now asking us to connect the acid concentrate. The acid concentrate is a liquid concentrate as with conventional hemodialysis. So we place the concentrate stick in the container and close the flap, and now the machine is asking us to connect the bicarbonate concentrate, which is a sterile powder in this case. So I will place the bibag here and close the concentrate flap. Once this is done, the machine is in a self-test where it is going to test all the alarms and the monitoring systems, and it is also now allowing us to start the loading of the blood lines. The machine with its screen will guide us through the entire process of loading all the lines which are required for this treatment. I'm going to start with the dialyzer. So I will place the dialyzer here on its holder, and now the machine is asking me to load the arterial line. The arterial line is slightly different from the conventional arterial lines. Among other things, it has the pump segment which has a diameter of 8 millimeters as opposed to the normal lines which have 6.4 millimeters, and this portion of the pump segment has a little spike which engages with a sensor on the machine. So let's do that. There, did you hear that little sound? That was the sensor engaging with the spike on the machine, and consequently this dome opens, which allows me to load the pressure pod into it. So I've loaded the pressure pod. This is the arterial line clamp. This is the blood volume monitor. And this is the blood temperature monitor. The blood line has a port here which is for pre-filter delivery of substitution fluid, and then it goes to the dialyzer just as in conventional hemodialysis. The pump started and drew in the arterial line, and now we are ready to load the venous line. The venous line, I'll start with the venous bubble chamber. This is the optical detector segment. This is the venous line clamp. This is the blood temperature sensor. This is the venous pressure transducer protector. It's built in on this set, and this port is for delivery of substitution fluid post filter. The machine self-test is almost completed. Here we can see in the dialysate menu that we have an option of auto flow. If a vascular access is not producing an adequate blood flow, we can set the auto flow on. When we set auto flow, we choose an auto flow factor. The default setting here is 1.2, which means the dialysate flow will be set at 1.2 times the blood flow. We can change this to 1.5. And the dialysate flow will then be kept at 1.5 times the blood flow. If we do not want to use the autoflow option, I switch it off, and then I have an option of setting the dialysate flow from 100 to 1000 ml per minute in increments of 100. As we can see here, the machine has completed the T1 test, and it is now asking us to connect the substitution set. This is the safe line. Like the blood line, it has a spike to engage on a sensor of the substitute pump, and this is the port connection for drawing the substitution fluid. This machine offers us an auto prime option, that is, we can prime the circuit with the substitution fluid instead of using bagged saline. So I'm going to do that here. There. This is the substitution port. I open the substitution port, connect the safe line to it and close it, and I'm going to connect the other end of the substitution line to my arterial line. I'm also going to connect my venous line to the rinse port with the help of this connection. So now the substitution line is connected to the arterial line, the venous line to the rinse port, and there's one more message that the machine is giving, and that is to connect the dialyzer couplings. So this is Fresenius, red to blue and blue to red, like with any other conventional dialysis. We close the flap, machine says start priming or rinsing. So I'm going to start. So now the machine says it is priming the dialyzer on the dialysate side, after which it is going to automatically start the substitution pump and prime the blood side. And that's what has happened. Now you can see that the substitution pump is starting. It's priming at 100 ml per minute, and I'm going to keep a priming volume of 1000. As we can see here, I set the machine to prime with 1000 ml of substitution fluid, which has now been reached. So I switch the pump off, and the machine is asking me whether I want to continue priming any further or exit. I'm going to exit, and we are now ready to start the treatment. The machine is telling us to connect the arterial line to the patient, the safe line before or after, as to the ports which I showed you earlier on the tubing, depending on whether we want to deliver pre or post substitution fluid, and the venous line also to the patient. Before we connect the patient, however, let's look at the settings on our machine. In the dialysate menu, we said earlier that we would be choosing a flow of 100 ml per minute. We have a dialysate sodium of 138, a bicarbonate of 35, and a temperature at 36.5. If we were to choose the option of using the blood temperature monitor, then we could switch on recirculation and temperature control. Once we do this, the machine will automatically adjust the dialysate temperature depending on the temperature change between the arterial and the venous line that we are prepared to accept, which is a maximum of 0.5. So once I set this to 0.5, the machine will ensure that the difference between the arterial and the venous temperature, line temperatures will be 0.5 degrees, and it will do this by adjusting the dialysate temperature automatically. So now the dialysate temperature during treatment will be automatically adjusted. Next, we have the ultrafiltration menu, and we need to set our patient's ultrafiltration. So we set an ultrafiltration goal. I'm going to choose 2 liters over here, and unlike in the 4008 series machines where we have a limit of 9 hours 59 minutes, we can do this as in a sled over a period of 24 hours. So we can go down to a very low ultrafiltration rate, which helps to promote hemodynamic stability in our ICU patients. So I'm going to accept that, and now I can choose my online hemodiafiltration. The options for online are hemodiafiltration, post-dilution, pre-dilution, simple hemodialysis, or hemofiltration. So if I choose hemodiafiltration post, the default setting here is the last treatment I did, that is that the machine was delivering the substitution fluid at a rate of 50 ml per minute. However, the machine also has the auto sub plus function. When I choose auto sub function, the machine will adjust the replacement fluid rate, monitoring the transmembrane pressure and the fluctuations in the venous pressure caused by the peristaltic pump of the blood tubings. As a protein layer forms over the dialyzer fibers, the pressure fluctuations will become attenuated, and the machine will use this to gauge the amount of clogging of the membrane of the dialyzer and adjust the substitution fluid accordingly, while maintaining the transmembrane pressure within a range of around 250 millimeters of mercury.